or not. So, interfaces. There are situations, okay? So first of all, I want to master the concept of an abstract class and a concrete class, and differentiate them very well. Abstract class is no more than a class that has one abstract method or more, right? And the problem with that is that once a class is abstract, it can no longer be instantiated, right? The reason why we have abstract class is because we are looking for standardization, correct? Now, there are situations in which, just like, remember the employee class? We had the employee and we had a salary in the hourly, right? We identified that they had many things in common, many attributes in common, like name, last name, sex, age, whatever you want to put there, right? And we identified that there were some common methods as well between them, correct? But there was one method that both of them had to implement, and that were meant to work the same way, meaning that both were meant to return a double. But the implementation in both of them was going to be different. Therefore, we couldn't find a common implementation to put in the parent. That's why we had to declare it as abstract, right? Right. But the functionality let's not call it functionality. The feature as such was the same, right? The feature was calculate salary. And that was the same. Both of them needed it, right? You understand what I'm saying? Think of a TV, for example. You have, say he has a Panasonic TV, she has a Sony TV, say he has a Toshiba TV. Okay? The functionality of pressing the red button in your control and saying turn on, right? That's the functionality, turn on. Let's call it a method, right? In your TV, that feature is necessary. In your TV is necessary, in your TV is necessary. Now, the way his Panasonic, her Sony, and her Toshiba implement and manage the signal and process it to produce the output of turning the TV on might be different, right? But the output is the same as having a screen on, right? You understand what I'm saying? So that's the same idea as abstract class, right? We're trying to look for standardization, right? So there are situations in which we have classes, we identify classes that behave differently, but we expect the same features from them. But it's hard to generalize them. Meaning that it's hard to generalize them, meaning that there is no method that is performed exactly the same way in all of them. But in all of them I want the same thing. I'll give you an example. All of you are familiar with a little bit of geometry. Right? We have three different geometric figures here. A triangle, a circle, and a square. How do we calculate the area of a triangle? Okay, this is all coming in the exam, guys, don't get scared. Okay, too hard, right? Okay. This guy?
R squared.
Good. Here.
Yeah.
You're a genius. Right? You understand what I'm saying? Sorry? You changed the math?
No, never mind. You got it.
Okay, okay. Look at this, what I'm putting in green. All the green things that I have put here is how to calculate area, right? Correct? Right. Is the area in a triangle calculated the same way as here as or here? No. Not at all. But do you expect to have that feature of calculating area in all these shapes? Yes. What else? Say perimeter. Do you know what perimeter is?
Yes.
Right? Perimeter in a triangle would be how long this is plus this, right? Assuming this were an equilateral triangle, and we had side S, would be 3S, right? 3 times S, right? Assuming all of them had the same size S, right? Is that clear?
Yes.
3 times S, right? S plus S plus S, right? That would be the perimeter, right? For a circle, is what?
2 pi r.
2 pi r, right? And for a square, 4 times L, right? Correct?
Yeah.
So far so good?
Yes.
Now, all these things I'm putting here is what? Calculate perimeter, for example, right?
We already need to do abstract now.
Good. He's saying, now, if you want to, for example, let's say I want to have my class triangle here. I want to have my class circle here. And I want to have my class square here. And all of them, I can say all of these guys are children of a generic class called geometric figure, for example, right? Or shape, whatever you want to call it, right? Correct? Now, you have identified that you have a method called calculate area and you have another method called calculate perimeter, right? But the implementations of each of them is going to be different. Yet, the feature as such, you want them to be present here, right? Now, we want to have them standardized because, let's say, Darlene works for Miami-Dade.gov. She works for the county, okay? And she's in charge of calculating, say, how much land belongs to private owners, okay? So pretty much she has to go, for example, to his house, check what's the area of his house. Maybe his house has a square shape. Calculate how much land that is, how many square feet that has. Then, at that, maybe Jukens lives in a house that has a circular shape. Calculate the area of Jukens, add up. Maybe he lives in a triangle house. Add up, you understand what I'm saying? Yes? And put them all together. The beauty would be that she could go to any house and say, calculate area. And the math of doing this, or this, she doesn't have to worry about. She knows that by asking calculate area, the system should tell her what the area is, regardless of what shape the house has. Is that clear?
Yeah.
Yes? So we want to have a standard way of asking, right? And we're meant to receive a double, for example, in both cases, right? So these two methods can be declared here as the geometric figure parent class as two abstract methods, right? Calculate area and calculate perimeter, right?
Yep.
Is there any method here that you can think of that is common to all of them? Most likely there isn't, right? There is nothing common to them, right? The only common thing is the name of the features that we expect from them. But as far as a common implementation that is that all of them will have,
We can divide everything by 2.
split,
By 2.
but in order to split you have to have the area first. So there is not much you can do. You understand what I'm saying? Yes?
Yes.
Yes.
You mean like that they all have like a method in common?
For example, in the employee class, we had the name, the last name, the sex, and we had the getters and setters that were common to all of them. All of them needed it, regardless if you're salary or hourly, we have that, right? But in the shapes here, what common thing do we have?
I see what you're saying.
You understand what I'm saying? There is nothing in common, right?
Right.
So when you have a class where you identify, pay a lot of attention here guys, where you identify that all your methods are going to be abstract, and therefore there is no attributes in common, there is no methods in common, that abstract class has only abstract methods, right? And that class is no longer called an abstract class, the class is called an interface, okay? The class is called an interface. So what is an interface? An interface is an abstract class where all methods are abstract. Make sense?
Yeah.
Professor, can I have a constructor in an interface?
No.
No, you can't. Okay? Because a constructor means that children can reuse that method. But if there is nothing common here, how can we have a constructor in the interface? And that's something that we have in the abstract class. In employee, we had a constructor, and we could reuse that constructor for the salary in hour. Here, it doesn't make sense anymore.
They can have fields though, right?
You can have fields. Not really. But you can have these constants.
Constants, that's what I mean.
Constants.
Could you run the definition again?
An interface is an abstract class where all methods are abstract. Okay? Simple as that. An abstract class is a class, an interface is an abstract class where all methods are abstract. All methods. So how do we create an interface?
So it doesn't mean more than two, it just means all methods.
All methods are abstract. There is no method that is concrete. No concrete method is present. So you create how do you create an interface? Just like creating a class. A new Java class. You can put Java interface. Now it's new. Let's discuss that. Or you can put your Java class and change it, whatever you prefer. Old school, I used to do it like that and call it, for example, shape. You said shape, right? And now what I used to do is come here and change class by int. Now this class has to be. Got it? In here, for example, we want to calculate area, right? This returns a double, right?
Yeah.
Professor, do I have to put abstract here?
No.
No, because if you're putting interface here, it's understood that all methods will be abstract, so you don't have to. In an abstract class, you have to because you can have a mix of both, right?
So you got rid of class?
Yes, you don't have class anymore. Now you put interface there. Is that there? And now, let's create, for example, a circle. Remember the word extends that I talked to you before? And I asked you to define in English what extends means. And some of you were saying extends means make something larger, make something that exists, grow, add more functionality to something, remember? Because extends means that, right? That something exists and we want to add something to it, right? We now extend to something that does not exist, right? So, in an interface, compared to an abstract class, in an abstract class or in a regular class, there is existent functionality. There are methods already, right? There are concrete methods, there is constructor, right? But in an interface like the one I just created, do we have any implementation?
Yes.
No, we don't. We just have methods, declaration of methods. That's all we have, right? You understand what I'm saying? So are we capable of extending anything out of it?
No.
Nothing, right? In an interface, all you're saying is, check out this my interface. My interface doesn't have any implementation, doesn't have any logic, only has declarations of methods, right? And I extend out of it. It doesn't make sense to extend out of here because there is nothing there to extend. So with interfaces, when you want to say that you are going to extend from an interface, you don't say extend, you say implement, okay? So here, now, if you want to say that you are a child, say, of shape, you have to write implement. I'm sure you've seen that word before. Right? Got it? Now, remember that I spent some time playing with you guys with this part? And I told you that when you have an abstract class and you have a child class that is concrete, it's obligated to implement any abstract method that the parent defined. Remember I spent some time explaining that? Remember? Same rule applies here. Okay? Same rule applies here. An interface is an abstract class, right? An interface is an abstract class, correct? So if I have a child that says implements this interface, what do you think? This class will have to implement every method from the interface, unless the class is good. In this case, yes.
I mean, I don't know if this would even make sense, but could an interface implement another interface?
No, because an interface will never be able to implement anything.
Oh.
Understand what I'm saying? If you put a word implements, you're promising that you're going to put a value for it. The interface don't put anything. So,
This one can be abstract as well as it would still be called a class circle in the shape.
to be valid abstract class. Hold on one second. Yes, Darren, right?
In your case here, E is an interface and X is an interface. How would you tie them together? If you don't extend
In
either
the
one.
example here, this is with abstract classes. These are interfaces. What I'm saying is, if this were an interface, then this class would have to, this class, if it's abstract, it's fine. It doesn't have to implement everything. It will say implements, but it doesn't have to implement everything. But this class and this class, which are concrete, they will have to implement everything that is here left. Like for example, here I have the interface shape, right? That has two methods, calculate area, calculate perimeter, right? My class circle is a concrete class.
Right.
It says implements shape. Here we have to implement every single method from the interface shape, which in this case are two, right? You were going to say something?
Oh, so since interface is not implemented, you can always be a parent class.
Yes, yes. The interface is just a parent class. So here, I can do whatever I want. I can declare, for example, my radius, right? I can put no, you won't see any super here because the interface doesn't have anything, right?
Right.
Doesn't have a constructor, right? Therefore, it doesn't make sense to have super, right? Everything is Docker, right? But I am obligated to implement the two methods, just the same way that they were declared here. So what you do normally, if you copy paste it to guys, here, and now make sure you put a value to it. For radius times my radius times math at 5, for example, right?
How do you shape the rectangles?
Shift that.
Oh, shape.
Okay, got it? Now, calculate perimeter, I have to implement this guy too, right? So here I'll do whatever I have to do. Return 2 times math at 5 times radius. Got it? Is that clear?
Yes.
Yes? And for the class, then you can do the same for the class square. You can come check class square. And you can have private, double, side, for example. So that's the length of the side, right? And then you have to implement those two guys. Oh yeah, my bad. My bad. I'm forgetting here to put increment. Right?
Yeah. Abstract.
And here will be, for example, return side times side, right? Here,
Side times four down.
4 times 2. Got it?
Yes.
Yes? Now, I don't care what I have. I can always use any of them, right? Again, I play with you in that class a little bit about polymorphism, right? So I'll do a small example again, and next class I'm going to introduce formally polymorphism. No, maybe not next class, but after we have a small quiz. Look what I can do. Remember I put a parent class and then a generic thing can be a specific thing. Remember we talked about that class? What is the generic thing here? The interface, right? So my interface is called shape, right? For example. And I can say if answer equals in our case, say circle, then s equal new circle. With radius say 1.5. Else s equal new square. With radius say 3. And then say area is a star. Is that clear?
Yes.
This is polymorphism, and this is the beauty of it. At this point, I don't care, and I don't know what S is going to be, right? Because depending if the user enters circle, maybe a circle, if the user enters square, it's going to be here. So at this point, when my finger is here, unless I run the program, I have no clue of what S is. S can be an object of square or an object of circle, right? But since both are implementing the same interface, I know that both have to have for sure this method exactly like this and this method exactly like that. And I can be confident of calling just the method and let Java figure out which calculator it has to call, the one from circle or the one from square, depending on how Java instantiated. Got it? Very good, right? If I run this program, I get a circle, for example. It's calculating the area of the circle, and it's giving you the perimeter of the circle. Is that clear, guys? Pretty cool, right?
Yeah.
You guys, prepare for your exam next class. It will be Java 1, all Java 1, and a little bit of Java 2, okay?
Is there any program we should look at specifically?
I will suggest everything, man. Look at everything, at least for the review, okay?